All right, today on Weird Facts, we're talking about a volcano in Antarctica that literally spews pure gold. But believe me, that's just where this incredibly strange story begins.
Welcome to Weird Facts. Hey, before we jump in, do me a favor and subscribe to the channel and definitely comment below what you'd like us to explore next. All right, you ready? Let's get into it.
Okay, look at this number, $6,000. What do you think that is? I mean, it could be anything, right? A fancy trip, some new gadget? Nope. The real answer is way, way weirder. That's how much pure gold dust gets blasted into the air every single day by just one volcano. And get this, it's in Antarctica. So let's meet the star of our show, Mount Erebus. This is the world's southernmost active volcano, sitting on a continent you probably just think of as, well, ice. But Mount Erebus is here to tell us that that picture we have in our heads, it's not even close to the full story. I mean, this thing is a real powerhouse. We're talking about 80 grams of crystallized gold being spewed out daily. That's so much that scientists can find this gold dust over 1,000 kilometers away. And the reason it's so active is that it sits on this really thin slice of crust, which basically gives magma a superhighway to the surface. Oh, and here's the kicker. It's had a nonstop, bubbling lake of lava since at least 1972. Just imagine that. Okay, so a volcano that spews gold is obviously incredible, but you have to wonder, right? Is this just some kind of weird geological party trick, a one-off spectacle on a frozen continent? Or is it a hint that there's something much, much bigger going on under all that ice? Well, the answer starts with this number, 138. Any guesses what that could possibly be in a place like Antarctica? That is the number of known active volcanoes in Antarctica. Yeah, turns out Mount Erebus is not alone, not by a long shot. In fact, Antarctica is home to the largest volcanic region on Earth. And the craziest part? Almost all of it is hidden under the ice. This whole setup is called the West Antarctic Rift System. You can think of it as a place where the continent is slowly being stretched and pulled apart. And that opens up these channels for hot magma to come rushing up. And so many of these volcanoes are just sitting there, miles beneath the ice, quietly pumping heat into the bottom of that massive ice sheet. So, okay, fire under the ice. You might be thinking, so what? I mean, a volcano buried under 2 miles of solid ice? Sounds pretty contained, doesn't it? Well, actually, that hidden heat has some absolutely huge consequences. It all boils down to this one key process called basal melting. It's pretty simple, really. The heat coming up from the ground, the geothermal heat, melts the very bottom layer of the ice sheet. And this creates this super important layer of water right between the ice and the rock it's sitting on. Let me give you a really simple way to picture this. Think of the ice sheet like a giant block of white chocolate sitting on a cool, tilted plate. It's gonna move, but really, really slowly. Now, what if you heat up that plate from below? You know, like one of those hidden volcanoes? The bottom of the chocolate starts to melt. It gets all slippery. And suddenly, whoosh, the whole block starts sliding down that slope way faster. And that's exactly what this meltwater does. It acts like a lubricant, making the glaciers slide towards the ocean at a much, much faster speed. This hidden volcanic heat is basically greasing the wheels. Okay, so this is where the story takes a really wild turn. We've got the volcanoes, we know they're melting the ice from below, but what if the thing that's triggering all this intense melting wasn't the volcanoes themselves? What if the trigger actually came from thousands of miles away? Some scientists are now looking into this radical new idea, and it's called the seismogenic trigger hypothesis. And honestly, it's a mind-bending idea. It suggests a direct link between two of the most powerful things on our planet, huge earthquakes and the stability of all that ice in Antarctica. So here's how it might work. When a massive earthquake happens, we all know it sends out those fast-moving seismic waves, the ones you feel. But this hypothesis says they also create something else, something called deformation waves. And these are waves of stress that move incredibly slowly through the Earth's crust. We're talking like a crawl, about 100 kilometers a year. Check out this timeline, because this is where it gets really compelling. Back in 1960, the most powerful earthquake ever recorded hits off the coast of Chile, a massive 9.5 magnitude. The theory is this quake sent one of those slow-moving deformation waves heading south towards Antarctica. For 35 years, it just traveled silently through the crust. Then, in 1995, it finally arrives at the Antarctic Peninsula. And guess what happens right then? The Larsen A ice shelf, which had been stable for literally thousands of years, just suddenly starts to collapse. Now, let's be super clear here. The mainstream scientific view is that this collapse is happening because of warming oceans and air due to climate change. And this new hypothesis doesn't argue with that. It just suggests there might be another piece to the puzzle. It's saying that maybe these distant earthquakes could be a contributing factor, a trigger that sends stress waves, wakes up those subglacial volcanoes, creates more of that slippery meltwater, and basically gives an already stressed out ice shelf that final push over the edge. You know, as one researcher said, the sudden transition of glaciers from a long-term stability to intense collapse requires an explanation. And that's really the heart of it, isn't it? These things were stable for thousands of years, even through other warm periods. So why are they collapsing so fast, right now? That's the question this whole seismogenic trigger idea is trying to help us understand. When you step back, what this theory is really telling us is that our planet is interconnected in ways we're just beginning to grasp. It paints this incredible picture of a world where a tremor on one side of the planet can, decades later, wake up a frozen giant on the other side and completely change the face of a continent. So we started with a tiny speck of gold dust from a single volcano, and we ended up with a planetary tremor that connects entire continents over decades. It just makes you wonder, right? What other hidden connections are out there, just shaping our world in ways we haven't even thought to look for yet? Hey, if you enjoyed this and learned something weird, do us a huge favor and give this video a like. It really, really helps the channel grow. Thanks so much for watching.